There is a problem with default values that we have to discuss, and that is when the default values are mutable, such as, for instance, lists. And in Python, that leads to a very unfortunate situation that we'll look at now. So here's the typical code, recursive code to reverse a list. If it's empty, we're done. Otherwise, reverse all but the first value, and then put the first value on the end. So it goes from the left end to the right end in the reversed list. This does not use default values at all, and it works just fine. Okay. Here is a new version of that that uses a technique we just saw some so far. In here, it's reverse so far. So sort of a tally as you go. Initially, it's empty. When you start, you want it to be empty. And then what we'll do is we'll insert the L of 0 on the leftmost part of this list. And then so that tallies up the reverse as we go. So let's go ahead and copy this. And we'll go here, and we'll paste, and we'll show you how this works. Okay, and let's get rid of that. And we'll go here, and we'll print L comma reversed so far. Okay, and I'll go ahead and run this. And I have to not have a typo. I run this, and here's what's happening. We're trying to reverse the list 2, 3, 4. So initially the list is 2, 3, 4, and we haven't reversed anything yet. We recurse, and now we're reversing 3, 4, and the reversed portion is just the 2 off the front. When we recurse again, now all that's left is 4, but we have reversed. The reverse so far is 3, 2, which is the reversed part of that part of the list. Then we recurse once more. Now there's nothing left, and the reverse so far is the reverse of that part of the list. That's what reverse so far is. This works. I don't know if it's the most elegant solution. In fact, it's not, but it is a solution. It works, or so it seems. But something really awful is going to happen. And to see what's going to happen, let's go ahead and print a reverse list of 5, 6, 7. And of course, we would expect to get 7, 6, 5. We don't. We get, let's actually turn off that print statement. We get 7, 6, 5, 4, 3, 2. So that's craziness. And what happened was this default value is assigned this list. We then mutate that list right here. We are modifying that list. Well, guess what? Python creates this list exactly and only once. So if you modify it, the next time you call from the outside, if you don't provide a default value, you get the old list, which is then modified. It's sitting there holding 432 already. So then it gets reused, and we couldn't possibly have wanted that. I suppose one solution would be to pass in the value here, but that's not, so it uses a new one, but that's not a solution at all, because remember, you cannot modify how it's called. Anything that's going to fix this, it's going to happen inside this function itself. We'll talk about the fixes in the next video.